Hi there, I've got a couple quotes here on the slide for you. It says, the first one, top left, every morning you have two choices. Continue to sleep with dreams or wake up and chase your dreams. The choice is yours. The top right says, sometimes the hardest thing and the right thing are the same. Interesting. Bottom right says, everything in your life is a reflection of a choice you have made. If you want if you want different results, start making different choices. Bottom left said, sometimes the right or the wrong choices bring us the right places. Bring us to the right places. Now, what do all these things have in common? Well, they have to do with choices. And they all are great quotes, great things to think about in your life because you have choices. You need to strive to make the best choices that you can, but you know what, at the same time, um, the wrong choices, you may learn from them. They might end up bringing you to a good place. And the reason I'm talking about this is, well, we're going to make some choices today in math. It doesn't have to do with changing your entire life, but it could make your life easier or harder depending on the choices you make. So our goal for this lesson in 6.4 um, is to choose the best method. So our goal is to choose the best method for solving a system of linear equations. And so far we've learned three methods, but if I give you a problem, I'm not going to tell you, I might not necessarily tell you which problem to choose. You got to choose the best method. All right? So here's something that the textbook gives us. It says choosing the best method. When to use. So the graphing method. Remember, that's where you graph the two equations and see where they cross. So it says when you want a visual display of the equations, so you can see them visually, or when you want to estimate a solution. Sometimes you have to estimate a solution when you're graphing. Substitution method. When one equation is already solved for one of the variables, so you have an x equals something or y equals something, or if it's easy to solve for one of the variables using that method. And then the last method, the elimination method, is say when the coefficients of one variable are the same or opposites of um, the other variable, or when it's not convenient to use either of the other two methods. So let's look at it a different way. We have the three methods again. Um, we have the graphing method, we have the substitution method, we have the elimination method. Remember, the graphing method, great when the equations are in slope-intercept form. So you want the equations in slope-intercept form. Honestly, if they're not in slope-intercept form, I would look for a different method. Unless it's really easy to get them both into slope-intercept form. So if they're both in slope-intercept form, boom, do the graphing method. Substitution method, here's what my advice would be. If one equation is solved for x or y, or both, because if they're both in slope-intercept form, they're both solved for y, so you could use a substitution method then. Um, but if at least one equation is solved for x or y, or if it's easy to solve one of them for x or y, then the substitution method is pretty good. I'll put that one in there. If it's really easy to solve one for x or y. These are three methods. When to use. This isn't how to use them, it's when to use them. And then finally, the elimination method. I would say it's best if they're both in standard form, where you have so both equations in standard form. Remember, that's ax plus by equals c. So in other words, the x term and the y term are both on the left side of the equation, and then you have a number by itself on the right side. And the other time, so if they're in standard form and if, and or if um, one of the variables has the same coefficient, like it's set up there. So the number in front of the variable, if it's the same in both equations. Because then remember with the elimination method, it's really easy then to use it to add or subtract um, both of the equations. So I'm going to give you three equations here, and I'm going to have you choose which one do you think is the best method for each. So first of all, let's start with the first one. Best method. Explain it in your own words. All right, I would use the graphing method. That's my choice because they're both in slope-intercept form. So then solve it. If it you could I mean substitution method would work great as well, but I would use the graphing method. If I have them like this, y equals 3x minus 1, so I'll start at -1. So I'm going to use this one for blue. 3x would be 3 over 1, so 3 up and over 1. 3 up and over 1. 3 up and over 1. There's my line. I can even go back right there. So there's my line as accurately as I can draw it. And then y equals 4x we'll do in green. There's no y-intercept, so you start at 0, and you go 4 up and over 1, 4 up and over 1, or down 4 and back 1. And I think that's where it is. That's where it's crossing right there. All right. So the solution then for that one would be right there, the ordered pair -1 and -4. I thought that was pretty easy. If they're in slope-intercept form, I'd graph them. So the second one, what would you use for this one? Look at it. What would you use? Well, my choice would be substitution. And my reason for it is one of them is already solved for, one of them is already solved for y. So right here I have y is equal to 3x plus 7, so I can just substitute that in for the y right there. So what I'd have then is 2x in the first equation plus 7. Now instead of y, I'm using 3x plus 7. That's my substitution. Equal to -20. Alright, then I can solve. Let's see, I'm going to get rid of parentheses. So I still have 2x, and then I have 21x and 49. 7 times 7 is 49 equals -20. Combine these to get 23x plus 49 equals -20. And then I'm going to subtract 49 from both sides. End up getting 23x equals -69. Divide both sides by 23 to get x equals -3, I believe would be your answer. Alright, and then remember you can take that -3, put it in for x in either equation. I'd put it back into this one. And I'd have y equals 3 times 3 plus 7. So it would be 9 plus 7. And that would be 16. And that would be my y. So my answer then would be x is 3, y is 16. You could plug those back in to check to see if those work. If you would plug them in, you'd notice I made a mistake. I meant to say -3 right here. So this is -3, and now I have to erase my answer here because I did this part wrong. Gotta plug in -3 for the x to find the y. So y is equal to 3 times -3 plus 7, which would be -9 plus 7, which would be -2. So my y is actually -2. There we go. That makes more sense, I think. Then you could plug them back in and find the correct solutions, and it would work out. All right, last and final one, number 3. How would you do this one? It says 5x plus 2y equals 17 and x minus 2y equals 8. How would you do that one? All right, well, my choice here would be to use the elimination method. And the reason my choice is to use the elimination method, I'm actually going to move this over for this one. Whoa, that was weird. Come on. All right, my choice is the elimination method because they're both in standard form. And if you look at it, if you add these, we have the same coefficient here, except they're opposite. So we can just add the two equations together, and this part would cancel each other out. So you have 5x plus 1x would be 6x. And then you have 17 plus 8 would be 25. Now this won't work out the best because x is going to be equal to, when you divide by 6, I'm just going to leave it as 25 over 6, and that's not the best to work with. But it is, well, either way, you're not going to get the best answer for this. But elimination method would be the easiest for getting one of the variables, and then you can plug that back in to get the other variable. So I'd maybe plug that back in for the second one, and then I'd get 25 sixth, which is like 4 and an eighth, 4 and a sixth. Um, sorry, minus 2y equals 8. Subtract 25 over 6. Subtract 25 over 6. Which should be 4 and a sixth. You'd end up having negative 2. And again, this is not, I would not give you a problem that would be this complicated, but negative 2 is equal to, it's going to be 3 and 5/6, I think. Divide both sides by 2. Divide both sides by 2, or negative 2. And you actually will end up getting, for an answer, you actually end up getting 1 in 11/12. So this is a really weird one with the fractions. But that would be your ordered pair. And the reason I chose elimination again is because we can cancel out one of the variables when we add the two equations together. All right, so that is choosing the best method for solving systems of linear equations. We have the 3 methods, so work on choosing the best one, the easiest one, when given the options to do any of them. All right, choices are a big part of your life, so have a good rest of your day.